Welcome to my talk. Good to have you all here. I'm going to talk in the next 50 minutes something like about our company, ING, what we're doing with streaming data, fast data as we call it. So I'm going to, what I will do is, hello. I'll explain a bit of what we do as ING, what our strategy is, and what kind of use cases we have for fast data. And after that, I will move on to some technology and architecture stuff. So if you have any questions, you can ask them in between, or you can save them for last, or I'll be happy to answer them as well online or afterwards. I'll be here as well at the conference. So don't hesitate to ask me anything. Let's start with this picture. Actually, this is a bit how we feel. That is us at the moment. ING is a big bank, so we are the elephant, right? The elephant in the room maybe, but elephant on the racetrack in this case. We're trying to compete with the small and agile fintech companies which are out there, and we're still ahead of the curve, as you see. But we have to, keep on improving and keep on challenging ourselves to get better, to stay ahead of the pack, basically. And I like this picture because it is a race. And we're here in Austin, and this weekend is the Grand Prix, right? Formula One. Who's staying over for the Grand Prix to watch it? Nobody. Really? Okay, maybe on television then, right? Okay. But that would be a great event. So that's about fast cars, right? Now we're going back to fast data. So who am I? I am Bas. I work at ING since over 4 years now. I have a role as chapter lead. What that actually means that I'm leading a team of data engineers. And I'm also doing some software architecture and development myself. I have an own background in artificial intelligence, but it was like in the old days when there were no such beautiful tools around. It was all a bit academic and a bit, you had to program your own neural networks, etc. But since the big data revolution is on us, everybody's doing AI and big data and machine learning. So that's great, I think, to be in at the moment. So I'm really happy that I can take this role at ING and lead the fast data chapter. I'll talk a bit about ING, what we're doing, and what we are actually doing with streaming data. First of all, this is the mandatory slides, of course, of our organization. ING is a big financial enterprise. We are actually one of the old banks, so being through lots of mergers, etc. But we have a large customer base now of over 35 million customers, mainly in Europe. We used to have, customers and offices and business in the US as well, but we sold it off, unfortunately. And that was actually during the financial crisis around 2008. We were doing really well. We were actually getting too big. So we decided to split off some parts. And now what was known in US as ING Direct is now part of Capital One. So if you are banking with Capital One, you'll probably still use the ING products and software, etc. And what is nice to know, actually, that's why, back to the first picture where the elephant was running, we got an award last year of being the best bank in the world. So that's good for marketing purposes, of course. And so we're doing something right. Hopefully we can keep up with that. And why did we win that award? Well, probably I think because one of the reasons is that we are trying to innovate continuously. And our CEO, Ralph Hamers, he positioned a strategy, it was like 3 years ago, where if you read what's on this page, it's actually saying, we are not a traditional bank anymore, but we are more an IT company with a banking license. Everything is becoming digital and becoming purely online. And as a bank, we have to be aware of that, and we have to be there for our customers in a digital way. So this strategy of ING, our primary purpose is to empower people to stay a step ahead in life and in business. That's already, you think, okay, well, that's already something, not connected to banking, like, what does it have to do with my financial products? It's more than that. It's not just that you can get a bank account and a mortgage with us. It's like we want to help you to be successful in your life and in your business. That's already something. But if you look at the strategic priorities, it gets even more interesting, because right here on number 2 is of our focus is that we want to develop analytics skills to understand our customers better. And that's actually what I'm going to talk about today. So all these things that we do with fast data, big data, etc., they are not just for fun. They are really part of our core strategy. And I think we are very lucky to have a management board that is really that is acknowledging that, and actually saying, we actually are an IT company with a banking license. And if you look at the landscape of the financial industry, this makes sense, because the banking industry and the financial enterprise are changing a lot. And we've been through, of course, many changes already. Right? In the past, people would go to a bank to actually physically store their money. Right? They would have an office where they brought, cash and maybe gold, and they would trust the bank to store it, and then they can take it away. And not so recently, actually, that whole function of the banking office was actually still there. So people were getting cash and were bringing their paychecks to the bank, and they were actually interacting with the bank in a personal way to get advice, for example, to talk to a banker, to talk about their financial situation, like how am I doing? Should I invest more in some stocks, or should I save money, or get a loan? Those kind of conversations. But I mean, nowadays, who's still going to a bank, to an actual banking office? I mean, at least I don't do it anymore. I interact with my bank in a digital way. So that's a real shift in this kind of technology, and we see that also of course in all the software that we use. By far, the primary channel, as we call it, to interact with our customers is the mobile app. So the mobile app on the phones or on the tablets of our customers, that is the primary interface of a bank. And that app is only 5 years old, something like this, right? So that's how fast things are actually changing. And we are in a competitive landscape. Back again to the first picture, the financial world is opening up. So we have lots of new laws and regulations that actually, in Europe, there's a law called PSD2, which is coming up, which basically says the customers should be able to bank with any organization they want if they authorize their bank to offer their services to another third party. So what that means is that if you have a bank account with us, with ING, for example, and if you allow a third party, like maybe a fintech app developer, working from his garage, whatever, to connect to your bank account, then we should comply to that. So that means that everybody can build a banking app nowadays. So that is actually, in a way, it is a threatening situation, because if we let that happen, and of course we have to let it happen, then there's a risk that these people still have some products at ING. They still, they have a mortgage and maybe a bank account, but they don't interact with us in a digital way anymore, and certainly not in a physical way anymore, because they have this nice, cool new app of a new fintech startup, or maybe even the apps of Google, Facebook, WhatsApp, Alibaba, you name them, who are actually also going to participate in the financial industry. So as a bank, you have a few choices in this competitive landscape. You can say, we'll let it as it is, and we'll focus on our products. So we have a product-focused strategy. We just offer you a mortgage, we offer you a bank account, a credit card, those kind of things, but we're not going to compete with all the new fintechs. But that's not what ING is doing. We said, no, okay, if we do that, then there's no primary reason that customers are actually going to go to us to do their banking. Because if we don't own the customer journey, as it's called, as we call it, then, what are we? We are only like a back-end provider, like a commodity. Because the products themselves will not differentiate themselves too much anymore. You'll probably have a slightly different interest rate on a mortgage, or you'll maybe have a credit card which has certain other aspects, but that's not really what customers will pick anymore. So we chose to actually try to be one of those fintechs ourselves, and to actually build new services on top of all the products that we will still have for decades. And then, what do customers expect of us if we are going to do that? Well, first of all, we have to be, of course, secure, reliable. We're still a bank, of course. So if we can think of all kinds of new ways of interacting with our customers. We can build all kinds of new apps. But the primary focus is always on the security, the reliability of the systems. But compared to like other services that you consume online, for example, Facebook and Spotify, you actually you want to be there always. You want to always be there for the customer in a digital way. And what we really want to do is like these services, be personal and relevant to these customers. So compare it back again to the old days where you were walking to a banking office in person, right? And talk to a real banker about their financial situation. Now that is personal and relevant, right? Because there's a guy sitting at a desk. He looks at my financial situation. He looks at my demands. He looks at what I want as a customer, and he gives me a personal advice at that moment to say, okay, yeah, you can maybe invest your money in this way, or hey, maybe you should refinance your mortgage, or whatever service you can offer. So that's personal and relevant. But if people don't come to the office anymore to do this kind of things, we should do that in a digital way. So that is actually one of the main strategies that we want to offer. Okay, what does this all have to do with fast data? Whoa, wasn't me. All right, still working. Good. We have if you look at this situation, then we have a few use cases for this, and I'll explain two major ones. One is fraud detection, which doesn't concern most of this personal relevancy, but it's something that we figured out. Hey, this is also a nice use case for our streaming data platform. And the other one is actionable insights, and that's actually the new way of giving people a personal and relevant advice instead of being a private banker. So in our website we have this is the main website, but also the app has this. We developed a new kind of way of interacting with our customers, where there's a lot of parts on the screen where we can actually do something extra for the customer. You can also call it, we're going to spam them, but of course we don't say it like that. But we want to be there to offer more than just insight in their financial situation. So if people log into their bank account, there's a few parts on the screen that actually can be personalized for your own benefit. And if you don't like it, you can also, of course, click it away. But this is the main screen that is there for ING customers. What we do is we call them actionable insights. So again, to get personal and relevant for this customer, we think there's a few things that are important in this. It has to be real time, and it has to be actionable. And actionable means that if you just show like a statement here, like say like just a message, that's actually not enough, because we don't know then if people like it or not. But if there's an action button there, a call to action, then we actually know, okay, how is this now being received by the customer? Because they will do something. They will ignore it, but then we also can detect it, or they will press the call to action, or they will might be snoozing it, and that gives us really a lot of relevant data about this customer. It's like talking to them, right, in a personal sense. So giving them lots of interaction on the screen and seeing how they respond to what we are actually offering them is crucial to keep improving this kind of service. So we already built this. It's already there, but it's batch driven. Like anything in a bank, basically. So I know who of you worked in a financial situation probably recognize this. Basically, how banks work nowadays is they do, most of the time, the systems do their work, but in the night, during the night, the real stuff happens. The real money transfers happen. The real, all the batch jobs kick in that make the banking possible. And that's also with our system here. So based on like the daily data of our customers, we run a batch job that actually predicts what customers might find interesting and relevant for them. And we show that to them once the next time they log in. That's already pretty good, but it's still looking backwards a day, because it's a nightly batch job. But we have some experience with it, so we can actually learn from this, like how people are responding to these kind of messages. So an example of this, how this works now, it's in Dutch, by the way. So sorry about that. But this is actually a real piece of actionable insight that we are actually offering to customers now, once they are running out of money. So. And why do we do that? Because if people run out of money and their debit card is going to go below 0, that will cost them money because you have to pay interest. So the message that you get here is, hey, we see that you are actually running out of money, but you have some money on your savings account. So do you want to restore the balance back to normal and actually transfer some money from your savings account, yes or no? And you see this customer online, he has a few options. He says, yes, I would like to do it right now. Or he has this button where he says, no, I'm not interested now, but remind me later. Or he can say, okay, I'm not interested in this kind of shit. Basically, don't bother me with this, delete it. And then we also know, okay, this is a customer that doesn't want to be bothered with this kind of things. So, but this is all batch driven. Right? So it also means that if we showing this to the customer, we also have to do again a validation check. Like, is this customer really now? Is he now still really in the red? Because this is based on data of yesterday, which is actually not so good. But it works, okay. But we can do better. We can do real time or near real time. So that's why we thought about and we started this project for like a year ago. We said, okay, let's build a streaming data platform, a fast data platform that can do the same stuff, but then we do it in real time. And looking at, okay, what do we need for this? Well, that's probably all the things you've heard today. The requirements are we have to have high performance, low latency, we have to have a scalable architecture, we have to be robust, of course, and we have to do some online machine learning and business rules management to make sure that the people are seeing the right information. Back to the second use case that I told you, this platform, we also want to use this for fraud detection. So you might wonder, why is this also secure and so fault tolerant, etc.? It's just giving some customers some messages. Yeah, that's true, but it's also, we also want to use it for the real core business of ING, which is, for example, fraud detection. So that was quite a challenging situation. We're targeting now two use cases, what I already mentioned, fraud detection and actionable insights. And we are currently in production with these two as well already. In the future, we might actually use this platform for multiple scenarios as well. So we're already thinking about the next steps. For example, giving people even better predictions of what they're actually doing. We have millions of customers, of course. So what we actually now do is we just analyze one customer's data. So based on your historical data, your transaction data, your behavior, we actually give you a prediction what you can do. But what if we can say to people, hey, based on customers with the same profile as you, we can recommend you this kind of products, or we can recommend you this kind of action to do to become more financially fit, as we call it. The platform currently works we have machine learning models there to make the predictions, but they are not, as we call it, connected in a direct feedback loop. So what I would say is if you have a true AI system is self-learning, right? It's capable of processing the feedback that we have of our customers, so all the buttons that they press, and rebuilding their model, retraining their model while they are doing this, basically. So we're not there yet, but actually that's what we want to do as a next step. So the retraining of the models now is just now done manually. And going back again to our strategy, we're also thinking about going beyond banking. This is all still connected to the banking account of the customers. But ING also wants to investigate new business models that actually they might have something to do with traditional banking, but they also are completely new markets that we encounter. For example, Internet of Things, with all the connected cars and the connected household equipment, etc. We can do some stuff in there, and we're experimenting with that as well. So, how does this work? Streaming data platform. A bit of the architecture. This is what it is. No. No. This is the picture that we started from a few years ago, because this is our data lake. And a data lake is a term that is also being used and abused many times, but we consider the data lake the reference architecture for basically all kinds of data-related software that we're building. And I have a simpler picture of that here. So this is a better one. Basically, this is a collection of tools that we use to store and process any kind of related data questions in the bank. So it can be a report, it can be an official data. We have to produce some data to our regulators, for example, to the European Central Bank, for example. That all comes from the data lake. And of course, we also have to service our customers in this way. So if a customer has a data-related query, we also want to serve this from the data lake. And when we started it, we started with batch. So this system was replacing a lot of old enterprise data warehouse systems. So we started with core systems that produce a daily batch, a daily data feed, a daily data export of the database, basically, and we reload that into a Hadoop cluster, storing the raw data over there. And from the Hadoop cluster, we do another ETL job to restructure the data in a data vault kind of way, which basically means it's a structured relational storage mechanism while we still are keeping track of historical data. So this whole data lake, of course, is the purpose of that is not to have the data which is there now in all the core systems, because you can also get it from the core systems themselves, but actually being able to time travel, being able to go back to the past, being able to produce a historical overview of one customer. So that's the bit of the bottom half of this picture. But now we are actually concerning ourselves with real-time streaming. So once the data lake reference architecture was designed a few years ago, there was already a place in that for real-time streaming, because we knew we had to do something with that. We only picked it up like a year ago to really work on this, and we set up now a Kafka bus for this and a Flink cluster for this. I'll talk a bit more about that later. So the streaming data platform itself has its own architecture, of course. What I said, it's running on Kafka and Flink. And what we did is, if you analyze this kind of things that we want to do with the streaming data platform, remember we have to do fraud detection and actionable insights, then you could say that in a data pipeline, actually there's a common pattern to everything that you want to do with your event data, your event-based data. So we built a system which is Kafka in, Kafka out. That's the first important thing to realize, I think. And all the data that we pull through the system to the streaming data platform follows two main steps. One is raw to relevance. I didn't invent the name, but okay. And the other one is the streaming engine. And this consists of two parts, the rules engine and the model execution engine. And there's a SAS logo over here as well. And that means that you can also use SAS if you just want to process your data rule-based. But if you want to do the fancy stuff with machine learning, you should use our Flink model execution engine. So what are these steps actually doing? The raw to relevance is like a software tool which actually does complex event processing. So if you're familiar with that, and I'll give you some examples of that in a minute, is that you actually have to aggregate the events that come in, because else you're nowhere. There's like millions of events being processed, of course, on the Kafka bus, so everything gets in here, all the raw events. Basically, all the transactions, so all the money that people are paying, all the ATM, all the credit card transactions, but also all the click events, everything that people do online is going on the Kafka bus, and we have to make some sense of that. But so the first step is always to do some filtering or aggregations to that, because you cannot just process all this data, you have to make sense of this. The first step is to make this relevant, make this interesting, so detect what is actually happening. And that is what we do in the first step. And then if you have then an interesting event, like something which is relevant for a customer, then of course you should do something with it. And so that's why you should apply a model to that to make, for example, an actionable insight. So that's the core architecture of the system. A little bit more in detail, these are the steps that we follow there. And so again, raw to relevance and the model execution engine for predicting the relevancy. And there's one other thing at the right here in the pipeline, it's called the processor. That's not actually doing anything really interesting. It's just making sure that the events are being formatted again in the format that we can use to for the next system to pick it up. And so our platform is only concerned with the true business value, with the true really the core event processing of this. It goes back on the Kafka bus, but then another system picks it up, for example, to make the actual notification. So, or to do a fraud case, to do a fraud alerting case, for example. Yeah, so I have some examples. So first one is, I think this is fraud detection. Yeah, yeah. So what's happening here? So we have a bunch of transactions. People are paying money, right? So this is actually one customer with withdrawing cash. At 9:14, he's in Amsterdam. He's withdrawing 150 euros. That's okay. At 10:10, he's withdrawing another 100 euros in Amsterdam, which is okay, sure. But then at 12:10, he's drawing another 100 euros in Berlin, which is a bit strange, of course, because how can I travel so fast from Amsterdam to Berlin in 2 minutes? So something's wrong here. So we call it the magic carpet syndrome, or the magic carpet pattern. Because if I would have a magic carpet, or maybe a Formula 1 race car, maybe I could make it happen, but normally no. So this is a possible fraud case. Yeah. So this is actually what we do, right? The transactions themselves, they just being loaded on the Kafka bus. We see all the events coming in, and sure, one of those transactions doesn't mean anything. It's not even interesting, right? Somebody takes some cash from an ATM, sure. But combining those events, so looking backwards in time, for example, one day, and comparing the actual geographical data of this one customer, that makes it interesting. That flags as an alert saying, hey, this might be an interesting fraud case. So there's a magic carpet scenario over here. But that scenario, if we detect it, that again is not good enough for us to do, for example, to block the transaction, because there might be something, this customer is doing which still makes sense after all. So we have to pick up this new event, this magic carpet event, and make a prediction out of this, and predict in this typical case what is actually happening. So what we do is actually we run a few models against this data. So the event data that is there, so the event data of all these transactions combined, together with the customer data itself. For example, we know that the customer has a certain age and has a certain the customer balance, etc. That together make the feature set, as we call it, that we're using to predict what we should do next. So we run 3 models. For example, in this case, it can also be 10 or just one model, and the one with the highest score will win, right? So there's, in this case, in this example, there's 3 options. First is we do nothing. We just ignore this kind of magic carpet because we know it's maybe a test scenario. Right? Could be the case. Option 2 is we stop the money flow, right? So because we see, hey, this is not right. So for this customer, we have to block this transaction. So he's not going to get this cash out of the ATM. And option 3 is, okay, this has happened too many times for this customer. We block the entire account. We block the card because this is somebody who's hacking into our system, for example. So these 3 models are the 3 options that we have. Then we take the feature set, we run them against these models, and every model will get a score out of the machine learning model. And the score is always a figure from 0 to 1. So make it easy. And if in this case you see this option wins. It has the highest score, 0.91. And actually, we now know what to do. Based on this scenario, based on the data that we see, based on this customer personal situation, we are going to block this transaction. So this also means that all this whole data pipeline has to happen within the instant that people are actually getting cash. So we did some real testing on how low latency we could get for this. The requirements for this kind of scenarios are about 200 milliseconds. So within 200 milliseconds, we should get the data, compare it to the historical data of the customer, combine it with his customer profile, score the models, and produce a new notification. And that's actually working at the moment. So another example, go through it a little bit quicker. Again, some customers doing something online, doing transactions, and this is somebody who is spending some money, right? In shops, for example. And we detect the pattern, hey, the customer is shopping. Because this is a series of events happening in the same afternoon. Maybe we know what geographical location it is again. Maybe it's in one city, like a customer in Austin who's just paying some stuff in some shops. So that's okay. Nothing. That's okay. Customer is shopping. But if they are spending money, of course their balance goes down. And actually, if customers are doing that, they might end up in a situation where they don't have enough money to pay their next shopping purchase. So the pattern that we can detect is actually that customers are shopping and that they are running out of money. A different scenario than the fraud example that I just had, but this gives an option to give this customer a little bit of financial advice. Because it could be that the customer is interested in, okay, hey, I see something happening, I see that you're shopping, you're running out of money, maybe we should transfer some money again from your savings account. Or maybe we just want you to know it and you say, okay, thanks for letting me know, and you continue shopping anyway because you're authorized to go into the red, for example. Or we could send a text message to your husband or to your wife, of course, and or WhatsApp notification. But same scenario basically, so this is where you actually beautifully see that this is not so different from detecting a fraud case. The same kind of data is being processed. Of course, we detect a different pattern, but we do the same steps. We do the same kind of a model evaluation. In this case, we have again the option to do nothing, or to send a text message, or to transfer some money from your savings account. And in this case, third option wins, and we actually give the customer an actionable insight, a suggestion to transfer some money from your savings account. This is code. People who like the code, I have some examples here, but probably if you're interested, then come after me later. I can show some more in detail. This is an example of how we actually score the models. So the middle part of the whole pipeline. And this statement here, so we run Flink with Scala, is actually what is doing this. So you see here, to get a prediction, to get the relevancy score, we actually evaluate a model, in this case a PMML model. We use technology for that, it's called OpenScoring.io. And we basically evaluate the whole feature set, the arguments of the data, combined customer data with event data. And the nice thing about PML, it's quite flexible, and actually you can use it in streaming pipeline. You can also use it just in a Java API, etc. And I'll talk a little bit more about that in a minute. Now, third example is another interesting one, which we can do, which is already now in production, is we can detect if customers are doing something online, but they might need some help. So, for example, we look at a different kind of data set now at the moment. We look at page visits. So basically the URLs that people are visiting. All that data is also coming on Kafka bus. We process it in the same way. And again, one of those things, one of those events is actually meaningless to us. It's just a person visiting a URL. Well, not really interesting, of course. But if we can detect a pattern there, with complex event processing mechanisms, we can actually see that a customer might be interested in something. For example, in a loan. Because to get a loan at ING, you actually have to go online, you have to log in, and you have to fill in a form which consists of 4 steps. And so what we expect to happen is that customers, they fill in form 1, 2, 3, 4 in that sequence in the amount of, like, say, 30 minutes. That's the usual customer journey, as we call it. So if we detect that a customer is doing steps 1, 2, and 3 in a reasonable amount of time, but then step 4 is missing, then maybe he has a problem. Maybe he's not interested anymore, of course. But it can also be that he's confused, he needs help, or something else is happening. So then what we can do is like we detect the pattern. So that actually the pattern in this case is not really that some steps are following each other, but basically the absence of the next step, which is there, which is also a characteristic of complex event processing. And we predict, of course, that the customer is unclear what to do. Again, the same steps. We have some models that we evaluate. The one with the highest score wins. Sorry. And in this case, we get the option to call the customer. So we actually generate an event that says, okay, let's call this customer up because he might be unsure what to do. And another code example, and we use some technology which is built in Flink at the moment. Flink has its own complex event processing library, Flink CEP, and that's actually really great if you want to program this kind of behavior. And what I like about this, it's actually very readable. You see all the steps that we mentioned here in the data, they're just here. Right? We have a list of steps, and we actually expect a pattern where and we look at the click events, where actually the start step is followed by step 2, then step 3, then step 4, within, in this case, 30 seconds, which is a bit ambitious. So should be 30 minutes, for example. So if this is not happening, so if only step 1 is being taken, or only step 2, and after this pattern fails, then this gives us an alert. Hey, this customer might be confused, or we might do something with this. That's it. Okay, to bring it all back together, this is the full diagram of like the technical architecture. You see that this is all the steps that I explained in a functional way. This is all the Kafka events that we store. So the raw events are the transaction, the click events. The business events are the events that are the interesting things that are happening. For example, somebody is shopping, or the event that somebody is following some loan request steps, but they're not finished. And the end event is that we create a an actionable event, a notification, for example. I already told you, we have not implemented online learning yet, but the models that we have here, of course, we get the feedback from the actions that customers are actually taking. So combine that with the data that we already have in our data lake, our customer data and our event data again, we can retrain the models. The data scientists are actually doing this. They retrain this kind of models, and they will be uploaded again to the Flink system. So that's what we do. We do offline training and online scoring. Okay, I'm going to dive a little bit into some technology. Why did we choose Flink? That's actually basically one of the first questions I usually get. It was not so obvious for us. Once we started this, there were only some tools available at ING that we could actually use. ING is of course very big. So this is an international project, but also in all the countries that we have our own IT, we have our own IT systems, our own IT department. So we already had some systems in place which could be, fulfilling this kind of business scenarios. For example, we are running Pega, we were running Infor, we actually are a big IBM shop, and we also had some experiment with Spark, mainly from the batch world. So a lot of systems were evaluated. And at the end, I said here we did a beauty contest, and that is actually about the time of year that was last year, December 2016, January 2017. We ended up with two main technologies that we would like to pick from, which is SAS and Flink. And with those technologies, we did a short experiment to find out which one suited us best. And actually, if you remember from the first picture, SAS still has a part in there because SAS still provides the rule engine. So we did not get rid of SAS altogether. But the main technology that we chose is Flink at the moment. So why do we do it? Well, several reasons. Flink is one of the engines that can offer true streaming capability, so truly event-driven stream processing, which makes it very fast. So compare this kind of things to, for example, Spark, which still has the micro-batching in place. Flink is simply faster. It's open source, so although we don't do everything open source, we are kind of fans of open source. And ING also wants to promote engineers to work with open source technology. So that was a big advantage for us. Open source also means, of course, it's cheaper. So there's also an advantage of using a tool like this. We proved the performance of Flink. We actually run some benchmark tests that came out really good for Flink, at least good enough. So we could meet all the performance requirements for this, and it works together with Kafka in a very nice way. So there's already connectors in place for this. Enterprise ready. We work together with a company called Data Artisans, which are the enterprise partners for Apache Flink, and they provided us with enough confidence that we say, okay, this is good enough for us to use in a bank actually. Of course, and if we use open source, we always have to run a lot of tests. We have to do code reviews, etc., etc. But they also came out pretty good. So that gave us enough confidence to say, okay, this is mature enough to use in a bank for us. And we like to program things in Scala. So my entire team is working only with Scala, and we used to work with frameworks like Akka and Spark. And Flink turned out to have a really nice Scala API as well. So we just liked it basically, right? If you saw some code examples that is mentioned, and Flink has I think a quite good way, a good syntax. It has a nice learning curve. You can start it. It has some tutorials online. You can follow, and in like 1 or 2 days, the people who were investigating this were actually really enthusiastic about this. I haven't talked about state management and about robustness actually yet, but that's one of the key features of the combination of Kafka and Flink, I have to say it correctly. In some cases, you'll probably say, okay, if my system has a failure, okay, we don't care so much. For example, if we cannot give an actionable insight to a customer, okay, sure, maybe after 1 hour we are back online. That's all fine. But if you look, of course, at fraud detection, it's crucial that your system keeps up and running. And Flink, out of the box, provides some real nice capabilities to make it very robust and reliable. And what is also a nice feature of the combination of Kafka and Flink, it guarantees exactly once processing, as it's called. So it guarantees that your events run through your system exactly once. How that works is actually that if you know a bit of Kafka, Kafka keeps track of offsets. So Kafka knows if you consume events from a Kafka bus, it knows where you're at. Basically, right? It knows, okay, you've processed this message, but the next one is still on the queue and you have not read it yet. And in combination with Flink keeps track of its internal state. So it keeps track of all the events which are in transit, basically. For example, if we do this kind of pattern detection, we have to keep track of all this data in a state. We store this data in memory, basically. That's the fastest way. But what Flink is doing is it's continuously making snapshots called checkpoints to store this state on disk. So if a failure happens, for example, if your system crashes, it's really nice that Flink knows, okay, I have processed this kind of state, and it's stored on disk in a save point or in a checkpoint, and let's reload it into my memory, and then keep on processing from my Kafka offset from where I have been staying. So this combination, the Kafka offsets with the Flink state, guarantees that your events will only be processed once, even if you get a failure in your system, because you just can travel backwards in time. You can know, okay, hey, my system crashed an hour ago. Okay, I'm just going to go backwards in time, and I'm going to process all the data that I missed in the last hour, for example. And we did tests with that as well, and it really works, and it's really nice. It's a really nice feature. Yeah, so some benchmarks we looked at as well. This is things you can find online. Basically, all the things that I said is depicted in these graphs as well. Flink is just extremely fast, and we did some tests ourselves as well, in which we proved the low latency and the high throughput of Flink as well. So in this graph, you see that we got on our test clusters, a test Kafka bus and a test Flink cluster of 10 nodes. We got a performance of the whole system of 42 milliseconds of latency. So the scenario that we tested was the shopping scenario. Remember the example that I gave, when we detect a pattern that somebody is shopping, we want to give him an actionable insight saying, hey, okay, maybe you want to transfer some money. That was actually a test scenario almost a year ago to prove the latency and the throughput of this. And we got a really good performance of this. The average data pipeline took only 42 milliseconds. And the amount of data that we could process in 10 test clusters, 10 virtual nodes, which is not so many, it was almost 500,000 events per second, raw events per second, which is pretty good actually. More than enough to cover all the data scenarios of this. Okay, I already mentioned that we use PMML as a data format. Actually, PMML is like an XML kind of data format that we use to store our models, and it's kind of the de facto standard if you want to do this kind of things. And Flink doesn't have its own machine learning library yet. It has one, but it's not good enough yet, actually. So what we do is we use a tool called OpenScoring.io to score these models. So in this way, we get a nice interaction with a data scientist. Data scientists can use any tool they want. These on the right side are some examples of them. Most of them use Spark, but they can also use SAS, for example, or they can write their own models in R or in Python, as long as they press the button export to PMML. And that export gives us an XML file that we can then store in a database. We can stream it into our streaming solution, and we can actually use that model to score all the events, which is it's good enough. It has some limitations as well because not all the models are covered, but for us it's working good enough at the moment. Yeah, so this is an example of this. Typically, we give a notebook to a data scientist. This is a Zeppelin notebook. We also have Jupyter notebooks if you want to work with Python. The notebooks are connected to our data lake, which has all the data in it, all the event data, all the customer feedback, customer profiles, etc. And the data scientists are doing their data wrangling there, and they are doing the creation of the models, the training of the models, etc. And at one time they give the statement somewhere here, export to PMML. They get this PMML file, which is basically XML, which we can load into the data stream again. Yeah, and the last slide of this technology pictures is that actually we also like Flink and this way of working because it connects well to our continuous delivery kind of operating model. So as data engineers, of course, we want to automate things. We want to make it possible for our software to be quickly deployed. And it also goes for our infrastructure. And Flink has built-in mechanisms that are really good for this. So we actually managed to integrate the whole building, compiling and deploying of Flink jobs in an automatic way with the tooling that we already have. So that was a pretty good selling point for us. So that was the story. Yeah, this is the summary slide. I think you can read it. I think I'm a bit over time, so I'm not going to reproduce everything again. Yeah, so I hope you enjoyed it. I think there's room for a little bit for a few questions. Right? And if you have a question, I was supposed to tell you have to walk to the central microphone.
How big was the team that did the migration basically from your data lake to this new Flink platform?
How big a team was?
Yeah.
It was 6 people.
Wow.
Yeah, but we're now bigger. We're now bigger. So we have now what we do now is I haven't really explained our operating model. We have a core platform team which is developing the platform, the infrastructure, and the middleware, etc. And they keep track of everything that's there. That's the core team, which consists of still 6 people. But then we have now 3 implementation teams, as we call it, who work on the use cases that run on top of the platform. So, for example, we have a team in Poland, we have a team in Netherlands, and we have a combined team of Belgium and Netherlands, and they will all work on a typical use case, for example, actionable insights or fraud detection, to make the software for this platform. So I think in total now there's like 20 people or something.
Amazing. And about how long did it take you to do that transition?
Sorry?
How long did it take that team of 6 people to implement?
It took, I think it took like half a year. So we started, as I said, we started this experiment in December last year. And the first use case that was running in production was going live this summer. So we took half a year to set up the whole structure, the continuous delivery pipeline, the data pipeline, the Kafka connection, everything together. Yeah.
Wow.
Yeah.
Amazing. Thank you.
Thank you.
On the 2 scenarios that you ran, those are machine learned models. How do you actually apply only like to unique ones? Like, because you seem to imply that the model is only applied to the individual. So I'm new to that realm. So can you just explain a little?
Yeah. Okay. Sure. What we do is the events contain the customer ID, basically. So the customer ID is our unique key to get more information, basically. And if you have just one event, it doesn't contain enough data to make a good prediction. But the event data contains the customer ID, so we know that customer blah, blah, blah transfers some money. And we can, of course, use that to make a call to the API of the data lake to enrich the data, basically. So, and sometimes we cache some data because some features of the customers might be reusable, so we actually store them in memory. But usually what happens is while we're in the data pipeline, at the moment that we actually want to evaluate a model, we fetch the customer profile, which is like 200 fields or something like this, typically, from the API of the data lake. We get it back, and then we have the enriched data set. Yeah, the feature set. Okay.
Hello. How do you deal with data privacy and data use? Like only some data can be used to score certain types of models and certain types of decisioning. How do you deal with that?
Yeah, we are really careful in this. So of course we have a lot of rules and regulations to comply to. So that's always the first thing to check, of course. And in terms of privacy, what we always do is we give customers the option to opt out of certain notifications, for example. If they do that, we don't send them any messages or notifications whatsoever in that sense. Yeah.
Hi, thank you for this section. I have a question regarding how you generate a PMML model in real time. Do you generate in real time, or you have a data scientist in doing that offline and doing the hard swap?
Yeah. The data scientists are working offline, so they build their model. They spend like a day building and training a model. They offload it to PMML. The PMML model is stored in a database in our case, and it's the bottleneck in the performance of the PMML. What we found out was actually loading the model. So loading the model into the framework. So what we do is that we do lazy loading. So we actually basically that means that we cache the models in memory. So once the new model is entered in a database, we know, okay, we have to stream it into to the Flink solution. We have to load it into memory. And once we do that, which takes a few seconds basically, then the scoring is extremely fast. It's a few milliseconds. Yeah.
Do you consider do the A/B test in real time? And another question is about how do you handle the outliers in real time?
That's a good question. We have the requirement of setting up the A/B testing for this, but we haven't done it yet. So we do a lot of A/B testing all over the bank, and actually our data analysts and data scientists, that's like one of their core ways of working, right? They want to compare their models. We have not built it yet, so it's on the backlog, so to say. So we will do it.
Yeah, because I have the similar scenario. I really want to do the real.
Yeah. It's a nice feature, but we should be getting there soon, hopefully. Yeah. Thanks.
Hi. A couple of questions. First question: how do you set up Kafka as a message bus in this particular case to guarantee exactly once consuming of the messages? For example, if you have a Kafka topic, let's say with 2 partitions, but you have 10 consumers, how do you make sure that not 2 different consumers are going to pick up the message? Still using batches.
We set up of course, the Kafka is set up in a distributed way. So and we work with topics based on the event data which is coming in. I have to say I'm not a Kafka expert, so I suggest I will forward your question to the Kafka team. Because all I know is that we use it and we proved it's working, and it's working from the Flink perspective.
I was mostly wondering if you still had to develop against at least multiple possible about the same message being consumed multiple times or not. And so, second question, which is related to that, is how do you store this stream of data in a way that is well, obviously it's going to have to be eventually consistent, but you have those events that come like all over the world, and that might be coming from different locations as well, and you need to do maybe fraud detection almost instantly to forbid transactions to happen. So how do you make sure that, for example, if a user makes a transaction in Europe, that's going to go probably to the data center in Europe, something like that, but another user makes a transaction on the west coast of the US, if this, do you have like a unique data center that will just handle all of this, or is it like distributed globally and then you somehow achieve eventual consistency, and that's when you actually deny the transaction in case of like fraudulent transactions? How do you solve this with your storage?
Yeah, it's true. There's some things that are eventual consistency. Only thing that we care about basically is the end performance, of course. So in fraud detection, it doesn't matter if things are eventually consistent once we store it, as long as we can make the performance requirements. And that's what we've been testing actually, and we still are doing it all the time. We are replacing a fraud detection system which has a certain performance characteristics, and if we can match that, then our system is ready to go basically. And that is it's still working as expected. Yeah.
So what do you use to store that data?
What do you use to store what data?
All the data that is coming in the stream, you have to store it somewhere to be queryable later. So how do you?
Yeah. In our data lake, you remember the first one of the first pictures that we have. We have a for the structured data, which we usually use to make the query. We use the IBM Netezza, or it's called IBM PDA. It's like a big data appliance for this. And we also have a Cassandra cluster available if you want to cache it a little bit more. Okay. Yeah, but usually a direct query goes to IBM Netezza. Yeah. I think we have to finish off, guys. Well, we're already a bit late, but do you mind making the question offline to me? Yeah. Okay. Okay. Thank you very much.